Okay, so differentiation.
What are we doing this again?
Differentiation. It's called differentiation. It's something new in your syllabus. Differentiation. Differentiation. So what I'm going to do is, before differentiation, I need to add something. Remember we looked at the sine rules, cosine rule and all that. So in your syllabus, there's something new, because I've seen the papers for June and March, to do with, you're supposed to know. So this is a short, I will do the first 10 minutes, we'll do the first 10 minutes before. Differentiation is also short. So we need to look at the sine graphs, the properties of sine and cos. I hope everyone has got a calculator. So what I need to mention to you is that sine theta, the value of sine, okay, of an angle, sine theta, the maximum value is 1, and the minimum value is -1. Okay, are we together? For cos theta, you'll find that from your calculator. If you say cos of anything, the maximum again is 1, the minimum is -1. So let's look at the graph, then it will make sense just now. The graph of y is equal to sine theta. You're required to know how to draw it. Y is equal to sine theta. Then I'll show you what you do in an exam if you forget how to draw it. It's not difficult. Then I'll look at certain properties. So sine theta, we'll put a nice graph like it. We said maximum, the maximum, we said the maximum is 1, and the minimum is -1. Okay, so let's have 0, 90 degrees. I'm going to divide into 4, 180, 270, and 360. Clear, everyone? Okay, and 360. Remember, these are degrees. Huh? Now, I want you to use your calculator. What is sine 0? So that when you forget, you can do that, even in an exam. What is sine 0, everyone, in your calculator? Just punch sine 0. Rukudzo, in your calculator, what is sine 0? Are you guys there?
0.
I don't have calculator. Sine 0 is 0.
Just 0.
What is sine? Yes, 0. What is sine 90? Should be 1.
1, yeah.
You see, you can do that. What is sine 180? Should get 0. Check in the calculator. Everyone. Michelle, I hope you've got your calculator there.
Yes.
What is sine 270? Should get -1. Then sine 360 is 0. Like this.
Yes, sir.
So what it means is I have like this, a curve, but it will be more smooth than this. What's happening to my software? Okay, so it will be, I don't know what's happening, as if someone is also trying to write on. I hope no one is trying to write on my, why is it doing that? So it will be, yes, like this. Are we together? But of course, my diagram, this will be exactly the same as that one. Okay, are we together?
Yes, sir.
Now, so I need to mention something here so that you see the properties. I'll do this so that we apply. I have to close this first, sorry, and reshade again. It's as if someone is trying to write on my board like the last time. Okay, so like this. I'll divide this. If I want to divide this, I'll call this the first quadrant, the first 90 degree. Can you see that everything is positive here? So sine is positive in the first quadrant, okay? And is positive also in the second quadrant. But it's negative in the third quadrant and negative. The first quadrant is 0 to 90. Second quadrant is 90 to 180. This one, it's positive. Then it's negative, there is negative. So you need to know that sine is positive in this quadrant. How does that help you? It helps you when we are solving equations that I'm going to introduce just now. And I'll explain that. For example, if I say sine 120, sine 20 degrees like this.
Wait, Mr. K.
If I say sine 20 degrees, look at this.
Okay.
20 degrees is in the first what? Quadrant.
Mr.
Like
K.
this. Yes. 20 degrees is in the first quadrant. Are we agreeing? Rukudzo? Look at this. I can also draw 20 degrees there because it's also positive in the what? In the other quadrant like this. So now 20 degrees is equivalent to, if I'm moving all the way like this until I'm there, it's actually 180 minus 20. So it's equal to sine, like I said, someone is trying, I'm not sure what's happening. Like as if someone is trying to write on my, it's also equal to sine 160. Are we together? Can you check that in your calculator? Do sine 20 degrees, find what you get. Then do
Yeah,
sine
sine.
160, you get the same answer.
Yeah.
Are we together? Because of this property that we have said, first quadrant is positive, second quadrant is positive. So if I do sine 30 like this, it will be also equal to, look at this, without looking, we know that they are both, so it will be equal to sine. So in general there, as long as sine is positive here, as long as the sine is less than 90 degrees, it means if it's sine 30, you are simply saying sine 180 minus 30, which is sine 150. You're doing the same thing here. So sine 150 and sine 30, that should give you 0.5. You can check both of them. They are equal. Are we together? Clear?
Clear.
Okay. Now, if we take a negative, let's take a negative now, something a negative, then I'll show you how we apply the quadrants. So if I say sine, I'm not sure what's happened. If I say sine, okay, it's never done that. It normally does that if someone is also trying to write on my. If I say sine like this, let's say one, as an example, let's say sine 225, like this, degrees. Huh? I want us to think of the quadrants first. So this session may take longer than what I thought before we introduce differentiation. So let's think of the quadrant. We said the sign is positive in the first and positive in the what? In the second. But it's negative in this and negative in this. So if this, all the way to this is 180, I'm sure. What's 180 minus that? What do you get? 45, huh?
Yes, sir.
45. So that it means like this, huh? 45 degrees here. But because it's also negative in this, I can also do a 45 there. I'm sure you now get it. Huh? So it means this sine 225 degrees is the same as sine of what? All the way we are always moving in this way, in this direction, anti-clockwise, all the way to that. So it's 360 minus 45. What is 360 minus 45? It's 350 now. So can you prove that punch sine 225 in your calculator should be exactly equal to sine 315? Is it equal? Equal or not equal? It's equal. I'm just wanted you to find out that they're exactly equal, like what I'm saying. I'm not worried about the actual value. Okay. Now, having said that, you can be given equations, something like this. I'll show you. Sine 3x is equal to 1 and asked to solve. To solve this equation. Sine 3x minus 1. So is sine 3x is equal to 1. So to solve this, we can simply do, what did I say? Okay, no, I didn't want this. Okay, this will be 2. No, you don't get this type of questions for now. Sine brackets, oh, what's happening here? So 5 sine x is equal to 2, something like this. Those are the simple equations that you get. So you divide both sides by 5, you can tell. Then we have sine x is equal to 2 over 5. Huh? Can you see? Then I'm simply finding the angle. Angle is arc sine 2 over 5. Normally they give you a range. They say your answer should be between 0 degrees less than or equal to x less than or equal to 360. So it means you don't just, what is your answer? Let's find that quickly, then I'll explain. We will use our quadrants to find what is. So normally you have two answers, huh? Not just one answer when you're given a range like this. So what is your answer, Jordan?
23.6.
Arc sine of 2 over, remember doing second function for sine, Michelle. If you haven't done this, it's arc sine here. I left the arc sine, not sine, arc sine. So it's second function for sine on most of your calculators. Second function sine brackets 2 divided by 5. You said 23.6.
6.
23.6. Michelle, are you there? 23.6 degrees. But look at what we said. Sir. We said, so this is first quadrant. If I want to do that. Positive, 23.6. But we can also have another one, because it's also positive in the second quadrant. Another 23.6. So it means our other angle is all this way up to that. So it's 180 minus 26.6. So, or what? What's 180 minus 26.6? 23.6, sorry. Yes, 156.4. Clear now? Done. That making sense?
Yes, sir.
Hope so. Okay. Now let's talk of cos theta. The cos theta graph. So it's fine, we'll do differentiation tomorrow. Cos theta, then we'll look at questions that they cos theta graph. So again, it's the same properties, positive maximum 1, then negative 1. So 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Clear now? Now, what is cos 0 from your calculator? Without me telling you what is cos 0. You should find that it's 1.
Yes, sir.
What is cos 90? The calculator should give you 0.
Yes.
Cos 180 should get negative 1. Cos 270. Yes. What is cos 270? 0.
0.
Cos 360, 1. You see? Without even memorizing this graph, if you simply know that, then you're simply drawing your nice, it's the other way, it's the opposite of sine, the sine graph. So like this. But these are nice curves, huh? Not the way I'm drawing it. Altogether. Yeah, but ideally they want you to sketch that. They won't penalize you for that. So now look, let's now analyze the properties. Huh? Remember, this is our first quadrant. We are dividing into 4, 360 into 4, 90 degrees, 90 degrees. Second quadrant, third quadrant, fourth quadrant. So I can now use the graph. If you have forgotten which quadrant is positive, you use the graph. Huh? So now where is it positive? In the first quadrant and in the last quadrant. So we have identified something. Cos theta is positive in the first quadrant and the last quadrant. Negative, negative. How do you get that? So which means if I say cos, for example, let's say cos 15, or maybe let's say cos let's say 50 degrees here. Well, it's positive in the first, so it's also positive in the last. So I'll have 50 degrees. And remember I said you always move like this. So all the way like this. I'm sure you now guess it. So it means cos 50 degrees is the same as cos 360 minus. What's 360 minus 50? It's 310, huh?
Okay.
Yes. So it means cos
What?
50.
Oh yeah, sorry.
Cos 50 degrees is equal to cos 310. Check that, Samantha, in a calculator, whether it's correct. Do cos 310, then do cos, you should get the same answer, cos 50. Same answer. Clear?
Yes, sir.
That is the same answer. We are using the properties of the quadrants. Huh? Okay, so we are required to know how to draw it. Then, okay. So let's start on the differentiation. We still have some minutes. So if I have an equation of a curve, or the equations that you have been drawing, y is equal to 2x squared minus x, yes, plus 5. What's your question? So differentiation, we're now starting. Y is equal to 2x squared minus that. Huh? So in general, Samantha, if I have y is equal to x to the power of n. So to differentiate this, I write dy over dx. I'm differentiating this with respect to x. It's simply equal to n x to the power of n minus 1. That's how simple that is. That's how I differentiate something. So e.g., if I have y is equal to x to the power of 5. Let's do that together. Dy over dx is equal to 5. We are following. X to the power of 5 minus 1, which is simply equal to 5x to the power of 4. Is everyone following? If I have y is equal to x squared, dy over dx, Rukuzo, is simply equal to 2x to the power of 2 minus 1 is what? Is 1. Following?
Yes, sir.
No.
If I have y is equal to, why is he saying no? X to the power of half.
Because I'm trying to tell you, my network cut out, so I missed half of what you said, Mr. K.
It's fine, I'm recording. Dy over, it's okay, I'm recording. I'm sure you'll catch up. Dy over dx like this is equal to, so I'm recording the video, that's fine, is equal to now half, x to the power of what? Half minus 1. Remember, it's always minus 1 here. Half minus 1, so that is half x to the power of minus half. Was half minus 1 is minus half. Are we together? If I have y is equal to x like this,
yeah,
dy over dx is equal, remember x is as good as x over 1. Yeah? So if it's simply 1 times x to the power of 1 minus 1, yeah? Which is simply equal to 1 multiplied by x to the power of 0. Anything to the power of 0 is 1. Yeah? So it's 1. So if I differentiate this, I simply get 1. Clear now?
Yes, sir.
Which means if I have 5x like this, if I differentiate, I simply get 5. Because this x here is, x always gives us 1. Differentiation of a constant like x is always gives us 1. So if I say, for example, y is equal to minus 10x. So dy over dx, without even thinking hard, is simply minus 10. Because the x here always gives us 1. Are we together? Now, let's go back to the equation that I had given you when we started this equation here that I gave you. Samantha, you're very quiet. Are you in the lesson? Sorry, Michelle.
Yes, sir.
So let's look at this equation there that I've just given you. Now, dy, let's do that first straight away. Dy over dx is equal to 2 times 2, you guess it, 4. But this is now 2, remember 2 minus 1, so it's simply x. There's no need to write x to the power of 1. Then this, remember I said the x always gives you 1, so it's simply minus 1. Then this, a constant always gives you 0 because there's no x here. Are you together? So this is our differentiation there. Then, what you now need to write down is that at a turning point, at any turning point, at a turning point of a curve dy over dx, or if you want to say dy over dx is always gradient. Gradient is always equal to 0. To 0. Dy over dx is always equal to 0. Are we together? Dy over dx is equal to 0. So let's look at one question, but we'll look at more such small questions next week. Find the coordinates of the turning point find the coordinates of the turning point of the curve y is equal to 4x squared minus 3x plus 2, like this. The coordinates of the turning point. So solution, we should know that at turning point, I'm writing in summary, at turning point, but you don't have to write that in an exam. At turning point, dy over dx should be equal to 0. That's the first thing. So now let's differentiate this. So dy over dx is equal to 4 times 2, 8. X to the power of 2 minus 1 is simply x. This, we said x always gives you 1. Yeah? So it's minus 3 like this. Then this gives you 0 because it's a constant. And we said this Rokuzo x squared should be equal to 0. So let's find the value of x straight away. Move the 3 the other side. 8x is equal to 3. So your x coordinate straight away is 3 over 8. That's your x coordinate. Now, if my x coordinate is this, I can find what the y value is there straight away. So to find y value, use the equation. Y value, use the curve equation. So let's use that. So it's y is equal to 4. What does x squared mean? It means the value of x times 2. So like that, squared, minus 3 brackets 3 over 8 plus 2. Okay, like that. Let's solve that together quickly. Or you can use our calculator. If you use our calculator, then you find that this is 4 multiplied by 3 squared is 9, divided 8 squared is 64, like this. Minus 3 times 3 is 9 over 8 plus 2, like that. Then use your calculators, find what that fraction it will give you there. You can use your calculator. It's called a over b there. Do that quickly there. Find what fraction you get so that we write the coordinates. So we now know that it's 3 over 8. Then the y coordinate, find that out. 4 brackets 9 over 64 close brackets minus 9 over 8, yes, plus Sorry. Plus 2. What do you get? I'm getting 1 and 1 over. I'm getting 1 and 7 over 16.
Yes, sir.
But
That's the
what's
same.
that as an improper? It's 23 over what? Over 16. So
Yes,
we are
sir.
done. That's the turning point of our curve. Okay, we'll continue from there. So let's switch on to the next lesson. Okay.
Okay. Thank you, Mr. K.